Hello! Today we're doing solving quadratic trigonometric equations. So what you are looking for is you're looking for one of your trig functions to be squared and one of them not to be squared, and that's a pretty good sign that it's going to be in the form of a quadratic. So we've got a few examples today. Let's get started.
Okay, first example. Solve cos squared x minus cos x equals 0 from 0 to 2 pi. Okay, so if we are solving any of our trigonometric equations in the form of a quadratic, we're solving it like we would normally a quadratic. So that means we are looking to factorize, we are looking to use a quadratic formula. This one is set up to be pretty straightforward. I can take out a common factor of cos x. So cos x as a common factor. Then we use the null factor law, cos x equals 0, or cos x minus 1 equals 0. So x is inverse cosine of 0. So where are my solutions? Pi on 2 and 3 pi on 2. And when is cos x equal to 1? Which is 0 and 2 pi. So our final solutions are 0, pi on 2, 3 pi on 2, and 2 pi. Example number 2, we have solve 2 sine squared x minus 3 sine x minus 2 equals 0, going from minus pi to pi. Okay, so this one's a little bit harder, but we can see it's in the form of a quadratic. We've got sine squared and then we've got sine, and we just look to see, can I factorize? If not, I might use the quadratic formula. This one we can factorize to 2 sine x plus 1 and sine x minus 2. Okay, so null factor law, 2 sine x plus 1 equals 0. So sine x equals minus a half. So x is the inverse sine of negative 1/2. So what are my solutions? Well, in my normal first cycle, when is sine a half? That is pi on 6. And I want negatives, that's the third and fourth quadrant. So that'll be 7 pi on 6, that's the third quadrant, and 11 pi on 6 is the fourth quadrant. Now, let's have a look up here. Remember, we want our solutions from negative pi to pi. Both of these are too big. These are bigger than pi. So I need to go back a solution. So minus 2 pi from each of these. So the first one will become minus 5 pi on 6, and this solution will be minus pi on 6, and these two are too big, so I'm going to exclude those. The other part is sine x minus 2 equals 0. So when is sine x equal to 2? And this one, of course, when is sine x 2? We know that sine goes from negative 1 to 1. So this is no solutions. Okay, so my final answer is minus 5 pi on 6 and minus pi on 6. Example number 3, I have 3 tan squared x minus tan x minus 3 equals 0, solving from 0 to 2 pi. Alright, this one I'll save you some trouble. This one we cannot factorize, so we're going to need to use the quadratic formula. But what I'm going to have here is I'm going to have tan x, and then that's going to be equal to negative b. Now b is negative 1, so it's going to be 1 plus or minus square root of negative 1 squared, which is going to be 1, minus 4ac, c being negative 3, over 2 times a. So that is 1 plus or minus root 37 over 6. So I have two solutions here. I've got tan x equals 1 minus root 37 over 6, and tan x equals 1 plus root 37 over 6, and this is also not an exact value that we're expected to know. So my x will be, using my calculator, if I use my calculator I get 0.868, and then the next one will be pi plus that one, so 4.01, and when I solve this one I get 2.439, and then add pi to that I get 5.58. Okay, last example for today, we have 4 cos squared x plus 3 sine x minus 3 equals 0, solving from 0 to 2 pi. Now here's an example. I've got cos squared, but in the other part of my equation I have sine. So I need to think that becomes pretty hard for me to solve, particularly when this one's cos squared. But I can remember my trig identities, that cos squared plus sine squared equals 1. So I'm going to change this one to sine squared. So 4, that's 1 minus sine squared x plus 3 sine x minus 3 equals 0. Now let's expand, so I get 4 minus 4 sine squared x plus 3 sine x minus 3 equals 0. Group all my like terms, so I get minus 4 sine squared x plus 3 sine x, and then I have plus 1 equals 0. Okay, so I don't like to have a negative coefficient on my squared term, so I like to multiply everything by -1. And then factorize. Now this one factorizes quite nicely. It factorizes to 4 sine x plus 1 and sine x minus 1. Okay, then I can use my null factor law, so 4 sine x plus 1 equals 0, or sine x minus 1 equals 0. So when is sine x equal to -1/4? -1/4, that's not one that I am expected to remember, so I need to use my calculator. 3.394, that's my third quadrant, and 6.031, that's my fourth quadrant. And when is sine x equal to 1? That one I do know is pi on 2. So my final solutions are pi on 2, 3.394, 6.031.
And there we go, solving quadratic trigonometric equations. So remember what you're looking for, one of them to be squared, one not. You might need to use some of your trig identities to get them the same to allow you to solve. But yeah, then we just solve it like a quadratic using the null factor law. Don't forget to smash that subscribe button, hit the like for notifications in the future, and I'll see you in the next video.